1.9 Velocity Time Graphs. In the last two lessons, we learned about position time graphs. We want to know how the position changes over time. In this lesson, we will learn about velocity time graphs. It's still time here, but instead of position, we have velocity. Here is a photo of a gas pedal and a brake and the brakes. What would happen if we step on the gas pedal? Well, we will go faster. That means that the velocity will increase. What will happen if we step on the brakes? We will go slower. Velocity will decrease. In both cases, we have acceleration. We know that when we have acceleration, the position time graph looks like this. But what does the velocity time graph look like? Well, when we step on the gas pedal, the car will go faster. So the velocity increases. So we know that the velocity has to go up like this. Let's check this out in this simulation. So we have constant velocity. Nope, we have acceleration. So here we go. We have position, velocity. As the car gets faster, the velocity goes up. Okay. And that's why the position graph goes up like a curve. It starts out slow and then goes faster, 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 while the velocity graph just goes up. It increases. What happens if the acceleration is 0? If there's no acceleration, then we have constant speed. When we have constant speed, the car goes like this. Let's try this again. Okay. When we have constant speed, the position might change, but the car is moving at the same speed. What happens to the velocity? Well, the speed is staying the same. That means that the speed is constant. Constant means staying the same. So what's going to happen to the velocity graph? Well, it also has to stay the same. As the car moves at the same speed, the velocity stays the same. So that's why we have a position graph here. And the velocity graph looks like this. Now be careful. A and B look like similar graphs, but they describe two different stories, two different situations. In A, we have a displacement, or you can also say position time graph, and this is moving at a constant speed. Constant speed. With B, this is not even though the graph looks similar, this is a velocity time graph. This is a velocity time graph. So B is a velocity time graph. The velocity is increasing here, right? It's increasing, so it's not constant. So we have acceleration. So the graphs look similar, but they're actually very different graphs. What if velocity is 0? If the velocity is 0, like the statue, or maybe as a person pretending to be a statue, the object is not moving. Again, the word we use is stationary. if the velocity is 0, what is the graph going to look like? Well, it's just going to be 0 the whole time. We look over here. This is at 0, 0, 0, 0. Because the object is not moving, we call this object stationary. Okay. Summary. So when we have acceleration, the velocity is increasing or decreasing. When we are moving at a constant speed, or just constant speed, velocity stays the same. If we're stationary, the velocity is 0. The difference between these two graphs is here is hard to see, but the velocity is 10. Here the velocity is 0. Example. So at A, we see that the velocity is staying the same. Velocity stays the same. The velocity is 4, so it's moving. So it's moving at a constant speed, because we know it's not 0. B, well, the velocity is decreasing. It's going down. So we have acceleration. It's accelerating. At C, the velocity is also staying the same. In fact, the velocity is 0. Because the velocity is 0, it is stationary. Okay? That's it for this video.